morning. I am Venkata Rao, Professor of Mechanical Engineering, IARE, Hyderabad. Now, I will discuss about the topic Traveling Salesman Problem by Branch and Bound Technique. So, in this, I want to discuss about the introduction, classification, branch and bound method, procedure, and examples. Traveling Salesman Problem. Suppose a salesman wants to visit certain number of cities allotted to him. He knows the distance, cost, or time between every pair of cities. His problem is to start from his home city and passes through each city once and only once and come back to his home city at a shortest possible distance or cost or time. Suppose number of cities are 2, there is only one route, no choice. If the number of cities are 3, in that case, number of routes are 2. In that case, we can calculate easily. Suppose if the number of cities are 4, in that case, we can get 6. That is factorial n minus 1. 4 minus 1 means 6 paths. In that case, also we can calculate the cost corresponding to the each path and then we can find out a best solution. But if the number of cities going on increasing, it is very difficult to find out the solution. So in that case, we can use the branch and bound technique. Suppose here the problem is 2 types. One is the symmetrical, another one is the asymmetrical. If the distance or cost or time between every pair of cities is independent of the direction of journey, then it is called as a symmetrical problem. Otherwise, if the distance or cost or time between one or more cities, one or more pair of cities is changing with the direction of journey, then the problem is called as the asymmetrical type problems. Okay. Now, we'll discuss about the branch and bound technique. Branch and bound technique is a systematic method for solving the optimization problems. It is an optimization technique used for minimization or maximization problems. It depends on the efficient estimation of the upper and lower bounds of the branches of the state space tree. It takes more time to solve the problems compared to other methods. It is used for solving other problems, traveling salesman problem, job sequencing problem, linear programming and non-linear programming and many other problems. Now, procedure. In the branch and bound technique, first we have to reduce the given matrix. Suppose the traveling salesman problem is given either by means of a graph or by means of a matrix. First we have to construct that matrix. Suppose if the matrix is given, then we have to reduce the matrix and calculate the reduced value. The reduced value represent the lower bound of the problem or cost of the first node. The cost of the first node. For reducing the matrix, first select the smallest element in each row and subtract this element from all other elements in that row and write that element on the right side of the matrix, right side of the row. Next, select the smallest element in each column and subtract this element from all other elements in that column and write that element below that column. Repeat the same procedure for all the rows and all the columns. Then add all the lowest elements written on the right side of the rows that gives the total reduction value in the rows. Similarly, you add all the smallest elements written below the columns that gives the total reduction in the columns. Now add the reduction in the rows and reduction in the columns that gives the net reduction, that is the lower bound of the problem or cost of the first node. Next step is step 5 is the construct state space tree to find out shortest route. So after reducing the matrix, so we have to construct the state space tree to find out the shortest route. For example, consider the space tree drawn for 4 vertices. So in this, I will explain how to find out the cost of the each node and how to calculate the path. Now, already we calculated the lower bound, that is, let us say that is 23. Now we have to find out the cost of the node 2. For finding out the cost of the node 2, we have to take the reduced matrix. We have to take the reduced matrix and we have to change the elements in the first row and second column to infinitives in that matrix. So we are having a reduced matrix. In that matrix, we have to change the elements of the first row and second column as infinitives. And also we have to change the element in the second row first column cell. So that is cell corresponding to the second row first column. That is also to make infinity, because the salesman do not goes to the again the starting point. So here salesman starts from starting point 1, that is city 1, and then he can go from 1 to city 2 or city 3 and city 4. Now we have to find out the cost corresponding to the node 1, node 3 and node 4. So first we have to calculate the cost of the node 2. So after modifying the matrix, we have to see is there any possibility to reduce the matrix further. If it is possible, we have to calculate that value also. After reducing that, we have to calculate the cost of the node 2. Cost of the node 2. The cost of the node 2. So the cost of the node 2 is equal to cost of route, that is from 1 to 2, that is the 1 to 2 plus actual reduction, that is C1. What is the total reduction in the first matrix? That is say actual reduction. And then if any further reduction is there, so that should be added. Any further reduction is there, that should be added. So then we can get the cost of the node 2. Cost of the node 2 is cost corresponding to route 2 1 to 2 plus actual reduction plus any further reduction R2. Then coming to the next step, that means we have to calculate the cost of node 3. We have to calculate the cost of node 3. Again, we have to take the reduced matrix. In that, again, we have to change the elements of the first row and the elements of the third column as infinitives, and also the element in the cell 3-1 is also to make it as infinity. So all the elements in the first row and all the elements in the third column and the element in the cell 3-1 we have to make infinity. Then again we have to calculate the cost of the node 3. For calculating the cost of the node 3, so we have to check up, is there any possibility to reduce the matrix further? If it is possible, we can reduce it. Now, the cost of the node 3 is equal to cost of route 1, 2, 3 plus actual reduction C1 plus any other reduction corresponding to the matrix, any further reduction corresponding to the revised matrix. So, now by adding these three, we will get the cost of the node 3. After that, again, we have to calculate the cost of the node 4. For finding out the cost of the node 4, again, take the reduced matrix and change the elements of the first row and fourth column as infinity, and also the element in the cell 4-1 as infinity. And now check up, is there any possibility to reduce that matrix further? If it is possible, calculate the reduction value. Now we can calculate the cost of the root 4. Cost of cost of node 4, that is equal to cost of route 1 to 4 plus actual reduction plus any other reduction corresponding to that modified matrix. Now, you see that we calculated, let us say the calculated values corresponding to the node 2 is let us say that is a approximate value 38. For the node 2, node 3 is 36 and the node 4 is 23. After calculating these node values, we have to select the smallest cost or smallest value. So in this, node 4 is having lowest value. Now we have to select the node 4. From that, what are the paths available? What are the paths available for the traveling salesman to go? So the other options are 4 to 2, from vertex 4 to vertex 2, or vertex 4 to node 4, vertex 4 to vertex 3. So let us say the route corresponding to vertex 4 to vertex 2, let us say node 5, and vertex 4 to vertex 3 is node 6. So in that case, we have to calculate the cost again. We need not explore for all the nodes. Only we have to consider the lowest node, lowest cost node only. So now we have to find out the cost of the node 5 and cost of the node 6. So the cost of the node 5. For calculating the cost of the node 5, take the modified matrix of the node 4. So modified matrix of the node 4. So we have to consider the matrix 4 only. That is the parent node for this 5 and 6 nodes. So we have to take the matrix of the node 4 and we have to change the elements of the fourth column and elements of the fourth row and elements of the second column as infinitives. Elements of the fourth row and elements of the second column are made as 0 and 2 to 1. In the cell 2 to 1 also we have to make infinity. In this stage is the salesman does not go back to the starting point. So we have to modify that. After modifying, again we have to check up, is there any possibility to reduce the matrix? Is there any possibility to reduce the matrix? In that case, if possible, then find out the reduced value. Then we can find out the cost of the node 5. The cost of the node 5 is equal to the cost corresponding to route 422 plus the cost of the node 4 plus reduction value. By using that, we can calculate the cost of the node 5. After calculating the cost of the node 5, next we have to find out the cost of the node 6. The cost of the node 6. To find out the cost of the node 6, again take the matrix corresponding to the node 4. Again take the matrix corresponding to node 4. Now, in this stage, again change all the elements in the fourth row and all the elements in the third column as infinity, and also the element in the cell 3 to 1 also infinity. Again, in this stage, the salesman does not go back to starting point. Now, after converting that, after changing the elements, now if there is any possibility to reduce the matrix, reduce it and also calculate the reduced value. Now, you can find out the cost of the node 6 like this. Cost of the node 6 is equal to cost corresponding to route 4 to 3 plus the cost of the node 4 plus reduction value. By using that, we can find out the cost of the node 6. After calculating the cost of the node 6, we have to check up which one is minimum. Let us say the value is corresponding to node 5, it is 30, and corresponding to node 6 is, let us say, that is 25. So in this, we have to select the minimum value. The minimum value is 25. That means we have to consider the node 6. After finding out the minimum value, now again check up the options for the salesman. So now the salesman has to go to from 3 to 2 only. That is only the city left. He has to go from node 3 to that is vertex 3 to vertex 2 only. So corresponding to vertex 2, let us say that node is 7. Now find out the cost corresponding to the node 7. For calculating the cost of the node 7, take the matrix of the node 6. Now take the matrix of the node 6. After taking the cost of the matrix of the node 6, again modify the elements in the third row and the second column as infinitives. Third row and second column as infinitives. Again, see, is there any possibility to reduce it? If possible, reduce it. Again, find out the cost of the node 7. The cost of the node 7 is equal to the cost of the root 3 to 2 plus 3 to 2, that is vertex 3 to vertex 2 plus the cost of the node 6 plus reduction value. Then we can get the value of the node 2. From node 2, you will go back to the node 1 only, so that we can find out the path. So cost of node 7 is equal to cost of root 422 plus cost of node 6 plus any further reduction R7. So draw the path based on the lowest cost. Now you see, so here after calculating that, we have to find out the path. So the lowest cost values are 1 to 4. So from 4, the salesman goes to the node 6, that is vertex 3, that is city 3. After that, he will go to the from city 3 to city 2, and then he will go to city 1. So the path is 1 to 4, 4 to 3, 3 to 2, and 2 to 1. He will find out like that. Then the cost is 25, like that. So the upper bound is 25. Initially the upper bound is infinitive, but after calculating that, we can say the upper bound is 25. So this is the procedure for finding out the solution of a traveling salesman problem using a branch and bound technique. Now we will consider the one example. So a traveling salesman wants to visit 3 cities, 2, 3 and 4, and come back to home city 1. The cost matrix for these cities is given below. Find minimum cost route. So the traveling salesman wants to visit 3 cities, that city 2, city 3 and city 4, and come back to home city 1. The cost matrix for these cities is given below. Find minimum cost route. We have to find out the path that will be helpful to the traveling salesman, and that will reduce the cost also. Now, what is the first step? What is the matrix given? 1 to 1 is 0. The matrix given is 1 to 1 is 0, 1 to 2 is 16, 1 to 3 is 11, 1 to 6 is 4. There is no meaning from going 1 to 1. So this option is removed by taking either dash or infinity. So I am removed these zeros by infinitives. 1 to 1 and 2 to 2, 3 to 3 and 4 to 4. So this option can be removed by taking as infinitives. So after that, the first step is we have to select the smallest element in each row. In the first row, the smallest element first. So what are the elements here? 16, 11, 6. Infinitive 16, 11, 6 are there. So the smallest element is 6. Next, second row, the elements are 8, infinity 13 and 16. The smallest element is 8. Next, in the third row, 4, 7, infinity 9. The smallest element is 4. Now, in the fourth row, the elements are 5, 12, 2 and 5, 12, 2 and infinity. The smallest element is 2. So now add all these values. 6 plus 8 is 14, 14 plus 4, 18, 18 plus 2 is 20. So the reduction in the row is 20. The reduction in the first row is 6. The reduction in the second row is 8. The reduction in the third row is 4. The reduction in the fourth row is 2. And total reduction is 20. So now we have to reduce that one. So reduce that one 6. So this will become 16 minus 6 is 10. 11 minus 6 is 5. 6 minus 6 is 0, corresponding to the first row. In the second row, 8 minus 8 is 0. 13 minus 8 is 5. 13 minus 8 is 5. 16 minus 8 is 8. Okay. Then the smallest element is 4. 4 minus 4 is 0. 7 minus 4 is 3. Infinity minus 4 means infinity only. 9 minus 4 is 5. So next, in the fourth row, lowest element is 2. 5 minus 2 is 3. 12 minus 2 is 10. 2 minus 2 is equal to 0. This is the reduced matrix. So after reduction in the rows, next we have to reduce in the columns also. In the columns, what is the minimum element here? This is 0. This is 3. This is 0. This is 0. That means we can reduce only in the second row, second column. We reduce only in the second row. So the minimum element is 3. So after reduction, we can get the matrix that is now. So first column will be as it is. So infinitive 0, 0. This is 3. This is 0. In the second column, the minimum element is 3. So that this is 10 minus 3 is 7. This is 3 minus 3 is 0. 10 minus 3 is 7. In the third column will be as it is and 0 and fourth column is 0, 8, 5. So this is corresponding to the reduction in the columns. So the reduction value is 3. The reduction value is 3. Initially in the rows, the reduction value is 20. Now it is 3. The total value is 23. Total reduction is 23. Now we have to take this reduced matrix for calculating the cost of the node 2 and cost of the node 3 and cost of the node 4. Now this 23 is the lower bound for the problem. So 23, the cost of the root may be minimum 23. So it may be more than that. So now the same thing is written here. So this is the given problem. After that it is reduced. Row minimum. Row minimum is 6, 8, 4, 2. That is the sum is 20. Next, this 6, 8, 4, 2 are reduced. So after reducing these values, you are getting this matrix. So that is infinity 10, 5, 0, 0, 8, infinity 5, 8. So like that I have shown that. Next, after this 3 is reduced. After reducing 3, the matrix obtained is this reduced matrix. Next, so in this, after reducing the matrix, we have to construct the state space tree. State space tree. We have to construct that. So the lower bound already we calculated as 23. The upper bound is infinity. We don't know what is the value of the upper bound. So in this case, we constructed the state space tree. Now we have to find out the cost of the node 2. We have to find out the cost of the node 2. For calculating the cost of the node 2, we have to take the reduced matrix. We have to take the reduced matrix. In the reduced matrix, we have to convert the first row and second column. First row and second column as infinitives. That means we are changing this one to infinity, this one to infinity, this one to infinity. So the first row, all the values are infinitives. And second column, in the second column also we have to make all the elements are infinitive. And 2 to 1 is also infinitive. 2 to 1 is also infinitive. After modifying the matrix, we have to see, is there any possibility to reduce the matrix? So in the first row, In the second row, infinity, infinity, 5, 8. In the third row, 0, infinity, infinity, 5. And fourth row, 3, 7, infinity, 0, infinity. So here, there is a possibility to reduce the matrix by 5. We have to reduce the matrix 5. So we have to subtract 5 in this row. Subtract 5 in this row. So this is the reduced matrix. This is the modified matrix. Then we subtracted 5. When 5 is subtracted, we are getting this is infinity, this is infinity, 5 minus 5 is 0, 8 minus 5 is 3. 8 minus 5 is 3. So this third row will be as it is 0, infinity, infinity, 5. And then 3, infinity, 0, infinity. After that, we have to check up, is there any possibility to reduce in the column side? So first column 0 is there. Second column all infinitives. Third column infinity 0, infinity 0. In the fourth column 3, 5, infinity, infinity. That means we can reduce it. How much we can reduce? 3 we can reduce. So the minimum value is 3. So we can reduce 3. So after reducing 3, we can write the matrix. So the first column will be as it is, and second column will be as it is, and third column will be as it is in the fourth column. So infinity 3 minus 3 is equal to 0. This becomes 3 minus 3 is equal to 0, and 5 minus 3 is equal to 2. This is 0. So this is the modified matrix. Modified matrix. So we can find out, that means it is reduced. The value of the matrix is reduced. We actually initially we have taken the reduced matrix and then we modified corresponding to the node 2, and again it is reduced. The reduced value is 5 in the rows and 3 in the columns. The total is 8. Total reduced value is 8. So the cost of the reduced matrix is 23. The cost of reduced matrix is 23, and the cost corresponding to root 1 to 2. The cost corresponding to 1 to 2 is 7. The cost corresponding to 1 to 2 is 7. So we have taken 7 plus 23 plus 8, 38. So after reducing, we have to calculate the cost of node 2. Cost of the node 2 is equal to cost corresponding to that root 1 to 2 plus cost of the reduced matrix plus reduced value. So by using that, you can calculate the cost of node 2. After calculating the cost of the node 2, again we have to calculate the cost of the node 3. So the cost of the node 1 is 38 and represented here. Next, coming to the node 3. Now coming to the node 3. For finding out the cost of the node 3, again we have to take the reduced matrix. Again we have to take the reduced matrix. After taking the reduced matrix, we have to modify it. How we have to modify? First row and third column as infinitives. So here 7, 5, 0 is there. So we have to make infinitive here, and infinitive, infinitive. And corresponding to the third column, we have to mark infinitive, 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 infinitive. After modifying that, we have to check up, is there any possibility to reduce it? In the first column, 0 is there. In the second column, 0 is there. Third column, infinity is there. In the fourth column, there is a possibility because 8 and 5 is there. Next, in the row, first, in this, is there any possibility? First row, no possibility. Second row, no possibility. Third row, no possibility. Fourth row, possibility is there. In the fourth row, we can reduce 3. So that means we can write this 3 minus 3 is equal to 0. 7 minus 3 is equal to 4. Infinity, infinity. So the same thing we are getting here. So in the fourth row, 3 minus 3 is equal to 0 and 7 minus 3 is equal to 4. And the remaining infinity, infinity. So in the row side, we can reduce 3. After reducing the matrix from the row side, next we have to consider the column side. Now you can check up, is there any possibility to reduce in the column side? First column 0 is there, second column 0 is there, minimum element, third column infinitive, and fourth column the minimum element is 5. There is a possibility to reduce it by 5. So now you modify it. So you subtract 5. First one, infinity. 8 minus 5 is 3. 5 minus 5 is equal to 0. Infinitive minus 5 is infinitive. So, it is also reduced. That means from the row side, it is reduced to 5. In the reduced 3 in the row side and 5 in the column side. The total reduction corresponding to the node 3 is 8. 5 plus 3 is 8. Then we have to find out the cost of the node 3. Cost of the node 3 is cost corresponding to 1 to 3 plus C 1 to 3 plus cost of the reduced matrix, this one, and reduced value. Reduced value is 8. So, and we have to see what is the cost of C 1 to 3. 1 to 3 is 5. So, right, 1 to 3 is 5. C of 1 is 23. Reduced value is 8 and total value is 36. So, we calculated the cost of the node 3 and that is 36. That is written here. Next, coming to the fourth node. So, again we have to calculate the cost of the node 4. For calculating the cost of the node 4, again we have to take the reduced matrix and now take the cost of the reduced matrix. So, this is the reduced matrix. Now, we have to change the elements of the first row and fourth column. First row and fourth column. So, now write 7. In place of 7, write infinitive. In place of 5, write infinitive. And then corresponding to the fourth column. So, in place of 0, write infinitive. Place of 8, write infinitive. Place of 5, write infinitive and infinitive as it is. And also, we have to consider the element that is 4 to 1. So, you cannot go back again in this stage. So, that you can consider 4 to 1, fourth row, first column. Corresponding to that also, we have to make infinity. In the place of 3, we have to write infinity. So, now this is modified. Now check up, is there any possibility to reduce the matrix? In the first column, 0 is there. In the second column, 0 is the minimum. In the third column, 0 is the minimum. In the fourth column, infinity. So that means there is no possibility to reduce the matrix. Now calculate the cost of the node 4. The cost of the node 4 is equal to the cost corresponding to 1 to 4 plus reduced value plus reduced value. Reduced value is nothing is there. It is not modified. So that we can write 0. 1 to 4. 1 to 4 is 0 only. And the cost is 23. And a reduction is 0. So the cost of the node 4 is 23. The cost of the node 4 is 23. Next. In this stage, we have to select the lowest node because the traveling salesman from city 1 to, you can go from city 1 to 2, 1 to 3, 1 to 4. 3 options are there. In these 3 options, you can select the smallest cost route. In that, you can select the smallest cost route. So, 1 to 4 is the smallest cost route, so that he can select that one. After that, he has to see what are the options available or what are the paths available to travel. Now, what are the cities to be visited? City 2 and city 3. That means you can go from 4 to 2 or 4 to 3. So, the vertex 4 to vertex 2 or vertex 4 to vertex 3. So, in this, you can take the nodes, that is, let us say 5 and this node is 6. Node 6 corresponding to vertex 3. So, that you can do like this. Okay, now. So, next, the same thing is represented here. Now, so the salesman can go from 4th node to node 5, that is corresponding to the vertex 2, and node 4 to node 6, that is corresponding to the vertex 3. Now, again, we have to take the reduced matrix of the node 4. We have to consider the reduced matrix of the node 4. So, this is the matrix corresponding to the node 4. We already calculated. We have to take this matrix. After taking this, we have to modify it. How to modify 4 to 5? That means we have to change all the elements in the 4th row. All the elements in the 4th row as infinity, and also all the elements in the second column infinitives. So second column infinity 0, 7 are there. So we have to make infinity. All elements in the second column are zeros, infinitives. And all the elements in the fourth row also infinitives. In addition to that, we have to take 4 to 2. That is vertex 4 to 2, and also 2 to 1 also infinity, because he cannot go back in this stage. He cannot go back to the starting point. So that we have to take 2 to 1 also infinity. After modifying these, again we have to check up, is there any possibility to reduce in the rows or reduce in the columns? That means reducing the matrix. So now in this case, in the second row, there is a possibility to reduce 5. So now subtract 5 from all other elements in the second row. The first row will be as it is. In the second row, infinity, 5 minus 5 is 0 and infinity. In the third row as it is, and fourth row as it is. Fourth row will be as it is. Now the reduced value is 5 in this. So now calculate the cost of the node 5. Cost of the node 5 is equal to cost corresponding to 422 and cost of the node 4 plus reduced value. So the cost of 422 is 7. 422 is 7, and cost of the node 4 is 23, and reduction value or reduced value is 5. So 7 plus 23 plus 5 is 30. So that the cost of the node 5 is 30, represented here. After calculating the cost of the node 5, now calculate the cost of the node 6. For calculating the cost of the node 6, again take the matrix of the node 4. Again take the matrix of the node 4. So again take the matrix of the node 4 and again change the elements of the fourth row as infinity and third column as infinitives. Third column and fourth row should be made infinitives. After that, 3 to 1 also to be made infinity. After converting that, we have to check out, is there any possibility to reduce the matrix? In this stage, there is no possibility to reduce the matrix, so that we can find out the cost. The cost of the node 6 is equal to cost corresponding to 4 to 3, cost corresponding to 4 to 3, and cost of the node 4 plus reduced value. In this case, reduced value is 0. Cost of the node 4 is 23, and cost corresponding to 4 to 3, cost corresponding to 4 to 3 is 0. Cost corresponding to 4 to 3 is 0. So add all the values. 0 plus 23 plus 0 is 23. So now the cost of the node 6 is calculated. So that is 23 only. Now the salesman has to take a decision. So either he has to go from 4 to 2 or 4 to 3. But the cost of the 4 to 2 is 30. The cost of 4 to 3 is 23. So he has to select the route 4 to 3 only. So the minimum cost is 6. Now we have to select the route from node 6. Now we have to select the route from node 6. Now you see here 4 to 6, the cost is 23. What are the paths available from node 6? That is vertex 3. There is only one route, because already 1 to 4, 4 to 3 are over. Only the one that is available is city 2, that is corresponding to the city 2. Now we have to calculate the cost corresponding to the node 7. So now for calculating the cost of the node 7, we have to take the cost of the node 6. So the matrix is given here. Cost of the node, cost matrix corresponding to the node 6 is given here. Now we have to change the elements of third row. All the elements of the third row as infinitive. All the elements of the second column are infinitives. All the elements of the third row and second column as made infinity. Now check up. Is there any possibility to reduce the matrix? There is no possibility to reduce matrix. So that the reduction value is 0. Now we can calculate the cost of the node 7. So cost of the node 7 is equal to cost of 3 2. Cost of 3 2. 3 2 is 0 only. Next, cost of the node 6. Cost of the node 6 we have to take. That is, what is the cost of the node 6? Cost of the node 6 also 23. This is the cost of node 6. Cost of node 6. So the reduced value is 0. So that 0 plus 23 plus 0. So cost of node 4 is 23. Node 6 also 23. So same thing, we can take cost of the node 6 plus this one. So the total cost is 23. Now calculated the costs of the all the nodes. So are all the vertices. Now from 1 to 2, note it is having 38. So that it is a high value. Kill this one. Next, 1 to 3. This is also higher compared to this. This is also, you can remove it. Next, 1 to 4. This is the lowest one. That means we selected the node 4 from a starting point to node 4. After selecting node 4, next check up. What are the routes available? That is from 4 to 2 and 4 to 3. From 4 to 2, the cost is 30. From 4 to 3, the cost is 23. So remove the route from 4 to 5. So that now the route available is 4 to 3. After calculating the cost of the node 6, next calculate the cost corresponding to 3 to 2. So that we found the total cost from 1 to 4, 4 to 3, 3 to 2. After coming to the 2, you can go back to the starting city or home city. So the path is 1 to 4, 4 to 3, 3 to 2, 2 to 1, and the corresponding cost is 23. So in this way, we can find out the cost by using the branch and bound technique. So this is a small example. Now I will take a little bit bigger problem. Now you see, in the previous case we consider only the 4 cities. Now we are considering 5 cities. A traveling salesman wants to visit 4 cities, 2, 3, 4 and 5, and come back to home city 1. The cost matrix for these cities is given below. Find minimum cost route. So here cost route from 1 to 1 is dash. That dash indicates it is not possible. That means either we can represent that one by a infinity or dash. So dash 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 means that route is not possible. That is, there is no meaning from going 1 to 1 and 2 to 2, 3 to 3, 4 to 4 and 5 to 5. So we need not consider that one. So that we can mark it as a dash or infinitive. Now what is the next step? Next step is we have to construct the matrix for the reduction. Is there any possibility to reduce the matrix? Now check up. First write the values, minimum values. Here the minimum value is 10. Here the minimum value is 2. Here the minimum value is 2. Here the minimum value is 3. Here the minimum value is 4. So first, for reduction of the matrix, first we have to select the smallest element in each row. In the first row, the smallest element is 10. In the second row, the smallest element is 2. In the third row, the smallest element is 2. In the fourth row, the smallest element is 3. And fifth row, the smallest element is 5. So what is the total value? 14 plus 10 plus 2. 12 plus 2, 14 plus 3, 23 plus 4, 21. 21 is the reduction possible in case of a given matrix by using the rows only. So after that, you can get the values by subtracting this. The first one is dash, second one is 10, third one 30, fourth one 0, fifth one 1. So subtract 10, 10, 20, 0, 1. So in the second one, 15 minus 2, that is 13, dash, 14, 2, and then 0. Corresponding to the third row, lowest element is 2, this is 1, this is 3, this is dash, dash or infinity, both are same. So that here, this is 2 minus 2 is 0, and 4 minus 2 is 2. Next 3. This is 16. This is 3. This is 15. This is the dash. This is 0. Next, here the smallest element is 4. That is 12, 0, 3, 12, dash. So this is reduced after deducting the small element in each row. Now check up, is there any possibility to reduce it further? Now you see here, is there any possibility to reduce it? Is there any possibility to reduce it? This is 3 minus 2, that is 2. So in this minimum value is there, 0 is minimum, this is 2, 0 is minimum, here 0 is minimum. In this is not possible. Now you see here, that is written here. So this is 10 plus 4, 14 plus 3, 17 plus 4, 21 in the corresponding to the row. And column side, you can reduce it. From the columns, after reducing this value, the column side, the value is, we can deduct 1 only. Here in this column, we can deduct 3 only, so that 21 plus 4. So that you can, here we can deduct 1, here we can deduct 3, so that this is 0, this is 0, this is 0. So that only 4 is possible for the columns. So by using this, you can find out the reduction in the column. So the reduction is, the column is 4. After reducing that, you are getting this matrix. After reducing this, you are getting this matrix. So 21 plus 5. 21 plus 4 is 25. 25 is the reduced value, and the reduced matrix is this. So this is the reduced matrix. So reduced cost is 25 and reduced value is 25. That indicates that this is the lower bound for this problem. The lower bound for the problem is 25. So after calculating this, we can see what are the other options available. For that, we have to draw the state space tree. We have to draw the state space tree. From node 1, draw a path. 1 to 2 is one route, 1 to 3 another route, 1 to 4 another route, 1 to 5 another route. These four possibilities are there. That means we have to find out the cost corresponding to 2, corresponding to 3, corresponding to 4 and corresponding to 5. So we have to find out the cost corresponding to 3, cost corresponding to 4, cost corresponding to 5. Now we have to find, next step is we have to find out the cost of the node 2. How to find out the cost of node 2? So in that, we have to take the reduced matrix. We have to take the reduced matrix, and then we have to change all the elements of the first row as infinitive and second column as infinitive, and 2 to 1 is also infinitive. After modifying it, we have to check up whether is there any possibility to reduce the matrix. If it is possible, then we have to find out that reduced value. Now, this is the matrix. Reduced matrix is this, and then we have to see, is there any possibility to reduce it. So in the row side, there is no possibility here. No, here no. First we have to change that one. So this is the reduced matrix. We have to make this one is infinitive. So infinity or dash. In the place of 10 dash, place of 17 dash, place of 0 dash, place of 1 dash. Next, corresponding to the 2, we can write dash, 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 dash. And also 2 to 1 is also dash. So this is the modified matrix. After modifying it, check up, is there any possibility to reduce it from the row side? From first row, no. Second row, no. Third row, no. In the fourth row, there is a possibility we can reduce the value by 12. We can reduce the value by 12. 12, this is the reduced, here 0 is there, no. Check up, is there any possibility to, if the minimum is 0, it is not possible. If it is different, then possible. It is not possible from this side. Now, you can check up whether it is possible in this case, in the first column also 0 is there, infinitive 0, 0, 0. Now you can see the reduced value is 0 only. Now find out the cost of the node 2. Cost of the node 2 is equal to cost of 1 to 2. Cost of 1 to 2 is 10. So that is 10 and reduced value is 25 and reduction is 0. The total is 35. So like that we have to find out the cost of node 2. After calculating the cost of node 2, we have to find out the cost of node 3. For finding out the cost of node 3, again write the reduced matrix. After writing the reduced matrix, change the elements in the first row and third column. We are considering the third node means we have to consider the third column only. So take all the values are dashes or infinitives. So dash 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 is not possible. So here and also 3 to 1 is also infinity. After modifying it, check up is there any possibility to reduce it. In the first row, no reduction. Second row, no reduction. Third row, no reduction. Fourth row, no reduction. Because 0 is there. If you subtract 0, no reduction will be there. 11, 0, 12. Again 0 is there. So row reduction is not possible. Is there any possibility in the column? In the first column, there is a possibility to reduce 11. So second column 0. Third column, no reduction. Fourth column, no reduction. Fifth column, no reduction. Now we can reduce 11. So subtract 11 from the first column and write the matrix. Subtract 11 in the first column and write the matrix. So the first row will be as it is. In the second row, 12 minus 1 is 1. And third row, this is infinity only. 15 minus 11 is 4 and 11 minus 1 is 0. The first column will be as it is. Now you changed 1, 4, 0. Initially 12, 15, 11 are there. Those are changed to 1, 4, 0 after deducting 11. Next corresponding to the second column, no change. Third column no change. Fourth column no change. Fifth column no change. Then the reduced value is 11. The reduced value is 11. Now find out the cost of node 3. The cost of node 3 is equal to C of 1 to 3. C of 1 to 3. 1 to 3 is 17. The cost of the node 1 is equal to 25 and reduction value is 11 and the total value is 53. 17 is corresponding to 1 to 3 and 25 is corresponding to the cost of the node 1 and R3 that is reduced value. Reduced value is 11. Reduced value is 11. So the total cost of the node 3 is 53. After calculating this, next we have to find out the cost of node 4. Now coming to the cost of the node 4, again write the matrix. Write the reduced matrix and now change all the elements of the first row and fourth column as infinitives. For first row and fourth column as infinitives and 4 to 1 is also infinity. So this one in place of 10, 17, 0, 1. So you put all dashes. Next here as it is and fourth column we have to take as infinitive or dashes. So now this is modified and 4 to 1 is also we put dash. Now check up is there any possibility to reduce the matrix. In the first column 0 is there. In the second column 0. Third column 0. Fourth column not possible. Fifth column 0 and first row not possible. Second row 0 only. Third row 0 only. Fourth row, fifth row. So that means in this case it is not possible. That means reduction value is 0. Now find out the cost of the node 4. Cost of the node 4 is equal to C2 1 to 4. 1 to 4 is 0. 0 plus cost of the node 1 is 25 plus 0. So that the total cost corresponding to the node 4 is 25. That is calculated and marked here. Then we have to find out the cost of the node 5. So again, for finding out the cost of the node 5, write the reduced matrix and change the elements of the fifth row, change the elements of the first row and the fifth column as infinitives or dashes. first row and fifth column as infinitives, and also corresponding to the 5 to 1, because the salesman cannot go back to the starting point. So that's why we are marking it as infinitive. That means not possible. So this is the modified one. Now check up, is there any possibility to reduce this matrix? So 0 is there, 0 is there, 0 is there, not possible. From here, not possible, not possible, not possible, not possible, not possible. And again, you can check up here, reduced value, cost of node 5. Node 5 is the element here is the node 4. We have to mark node 4 here. So this is the reduced matrix 7. This is the reduced matrix, this and this. So here, any possibility here, here we can see this is the reduced this is the modified matrix. So in this case we can reduce it 3 is the minimum, so we can write 3 here, and here we can write reduce 2, because this is the reduced matrix. After reduced matrix, this is the modified one. This is the modified one. That means replace the first row as well as the fifth column as infinitives, and 5 1 is infinitives. After that, we found 2 reduction is possible in this row and 3 reduction is possible in this row. So the total reduction is 5 possible in the rows. So after reducing this one, you are getting these values. In the column side, reduction is not possible. So the total reduction is 5. Then the cost of the node 5. So 1 to 5. 1 to 5 in the given matrix is 1. 1 to 5 is 1. And then this is 25. Cost of node 1 is 25 and reduction is 5. The total cost is 31. So we calculated the cost corresponding to node 2, node 3, node 4, node 5. So these are the options available for the salesman to go from starting point 1 to 2 or 3 or 4 or 5. Now he has to select a route based on the minimum cost. So among all, the node 4 is having lowest cost, so that he will select first for the node 4. After selecting the node 4, he has to find out what are the routes available. Now, so after selecting the node 4, he has to find out the routes available. That is 4 to 2 and 4 to 3 and 4 to 5. There are 3 nodes are available. 3 routes are available. So the node 6 corresponding to the 4 to 2 route, node 7 corresponding to 4 to 3, node 8 corresponding to 4 to 5. So these 3 are available. So that we have to calculate the cost again, node 6, node 7 and node 8. So how to find out the cost of the node 6? So for finding out the cost of the node 6, we have to take the cost of the node 4. We have to take the matrix of the node 4. So reduce the matrix of the node 4 we have to take, and then we have to make all the elements of the fourth column as well as the all the elements of the fourth row, all the elements of the second column as made infinity, and 2 to 1 is also infinity. 2 to 1 element. Now cost of the node 6. Cost of the node 6 is this. So in this case you can find out. So we made, this is the node 6. Node 6 we made it as, this is already infinity. We have to make root 4, that is the node 4, fourth row, dash 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 dash, corresponding to fourth and second column also we have to make dash dash dash. After modifying it, we have to check up, is there any possibility to reduce it? Here there is no possibility to reduce it, so the reduction value is 0. Now calculate the cost of the node 6, that is C of 42. What is the value of C of 42? 42 is 42 is where is that? In the matrix node 4 we have to see the 4 to 2, that is 2, 4 to 2, and the C of 4 is 25. This is 3 and this is 0. Then this is 422 is 3 only. 422 is 422. 422 is 3. 3 plus 25 plus 0, that is 28. So calculated the cost corresponding to this one. Next, coming to the node 6. So we have to, node 6 is over. The cost of the node 6 is 28. Similarly, the cost of node 7. So again we have to take the cost matrix of the node 4 and we have to modify all the elements of the fourth row as well as the all the elements of the third column made infinity, and also corresponding to the cell 3 to 1 also infinity. Now you can see here. Now this is cost of node 7. So this is the matrix corresponding to the node 4. We have to make all the elements of node 4 as in infinity or dash, and 3 as dashes. Then we can modify it 4 to 1, 4 to 2 to 1 is also we have to make infinity. 2 to this is 3 to 1. 3 to 1 we have to make because we are calculating the node 7. 3 to 1 is also infinity or dash. So this is modified. After modification, you check up, is there any possibility to reduce the matrix? So now in this 11 is possible. 11 is possible. In this 2 is possible. That means in the row side we can reduce 2. In the column side we can reduce 11, so that we can reduce the total value is 13. And also see 4 to 3. So we can find out the value of 4 to 3 is 12. 4 to 3 is 12. This is the 4 to 3 is 12, and the cost of the node 4 is 25 and this is 13. So the total cost of node 7 is 50. The total cost of node 7 is 50. Now after calculating the node 7, then we have to find out the cost of the node 8. For calculating the cost of the node 8, again we have to take the reduced matrix of the 4 and modify it as all the elements in the fourth row as dash or infinity, and fifth column is also infinity, and 5 to 1 is also infinity or dash. Now here, so this is the matrix corresponding to the node 4. This is the modified, and we have to check up, is there any possibility to reduce it? So this is the modified one. We can reduce it by 11 here. So in this row, after this reduction of 12, you will get this matrix. This is corresponding to the node 8, reduced matrix corresponding to 8. Then find out the cost of the node 8. The cost of the node 8 is equal to C of 4 to 5. C of 4 to 5 is equal to 0, and the cost of the node 4 is equal to 25, and the reduction value is 11, and total cost is 36. So we calculated the cost as node 6. Node 6 is 28, node 7 is 50, node 8 is 36. So in this we have to select the minimum values. So in that, the traveling salesman has to select the lowest one. So the node 6 is the minimum. From that node 6, he has to draw the paths or options available to go. So from node 6, he can find out the paths available. From the node 6, there are two routes are available. One is 2 to 3, because already 4 is over. 1 to 4 is over. Next is available only 3. 2 to 3 and 2 to 5. So after finding the paths, we have to find out the cost. These are the options available to the traveling salesman. Either he can go from node vertex 2, that is the city 2 to city 3 or city 5. So in that case, he has to calculate the costs. Either he can go to the city 3 or city 5 based on the costs obtained. So first we have to find out the cost of the node 9. Cost of the node 9 you can find out by taking the reduced matrix of the node 6. We have to take the reduced matrix of the node 6, and then it has to be modified. How it has to be modified? We have to take all the elements of the second row and all the elements of the second row and all the elements of the third column as infinity, and 3 to 1 is also infinity. By modifying that, we can, after modifying, again we have to check up, is there any possibility to reduce it? If any possibility is there, we have to reduce it. So in this case, you will get the reduction may be 13. So you can see here the reduced values. After modifying it, we have to find out. Now here you can reduce 11, here we can reduce 2, the total is 13. So the cost of the node 6 is 28, then 30, and C of 2 to 3. 2 to 3 is 11. So that you can find out the cost of node 9. Similarly, we have to find out the cost of node 10. For finding out the cost of the node 10, again we have to take the cost matrix, reduced matrix of the node 6, and then we have to modify it. All the elements of the second row as infinity, and fifth column as infinity, and 5 to 1 is infinity. After modifying it, again we have to check up, is there any possibility to reduce it? So this is the matrix after reduction. So there is no possibility, so that it is 0, and the element 5 to 1 is also the reduced matrix. You can see here, we have to see that this is 2 to 5. 2 to 5 is 0 here, and 0 plus 28, 0, that is 28. So now, so after calculating the cost of the node 5 and node 10, he has to take the decision. Again, he has to go from city 2 to 3 or city 2 to 5. So city 3 is 52. The cost of node corresponding to that is 52. Node 9 is 52. Node 10, that is corresponding to 2 to 5, is 28. So the minimum is 28. So select the node 10. Now after that, selecting the node 10, that is the city 5. Next we have to select the options or paths available. From node 5, there is only one possibility, that is 5 to 3 only. So 5 to city 5 to city 3, because already started from city 1 and went to city 4, from city 4 to city 2, from city 2 to city 5, now city 5 to city 3. Now we have to calculate the cost corresponding to the city 3 or node 11. So node 11, so we have to, for finding out the cost of the node 11, we have to take the node 10. This is the matrix corresponding to the node 10. Then it has to be modified. So how to modify? So we have to take all the elements of the fifth row as infinity and second column as infinity. Then we have to check up, is there any possibility to modify it? So there is no possibility to modify, so that the reduction value is 0 only. And then so the cost of node 11 is 5 to 3. 5 to 3 is 0 only. This is 0. This is 5 to 3. Then C of 10, the cost of this is 28 plus 0. So 28. So now we have to find out the path. Path is, because 1 to 4 is 25, 4 to 6 is 28, and 6 to 10. That means 1 to 4, 4 to 2, 2 to 5, 5 to 3, 3 to 1. 1 to 4, 4 to 2, 2 to 5, 5 to 3, 5 to 3. 1 is the, this is the path, and the corresponding cost is 28. The lower bound corresponding to this problem is 25 and upper bound is 28. So this is the procedure for finding out the solution of a traveling salesman problem. If any number of cities may be there, then by using this branch and bound technique, we can find out the solution. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.